Hi, this is Algebra 1, Module 7, Lesson 6, Factor Fixin'. So we have new types of quadratics we're looking at today. At first, Optimus Quilts only made square blocks for quilters, and Optima spent her time making perfect squares. Customer service reps were trained to ask for the length of the side of the block X that was being ordered. They would let the customer know the area of the block to be quilted using the formula A of X equals X squared. Opti- Optima found that many customers that came into the store were making designs that required a combination of squares and rectangles. So Optimus Quilts has decided to brew several new lines of rectangular quilt blocks. Each new line is described in terms of how the rectangular block has been modified from the original square block. For example, one line of quilt blocks consists of starting with a square block and extending one side length by 5 inches and the other side length by 2 inches to form a new rectangular block. The design department knows the area of this new block can be represented by this equation right here. But they do not feel that this expression gives the customers a real sense of how much bigger this new block is. For example, how much more area it has when compared to the original square blocks. So, can you find a different expression to represent this area of this new rectangular block? You'll need to convince your customers that your formula is correct using a diagram. So, I'm going to go A of X equals, so we have an X plus 5 on one side and an X plus 2 on the other side. So if we're going to use a diagram, what I basically have is X by X. One side, I have 5, 1, 2, 3, 4, 5. And the other side, I have 2. Oop, not very good at lining these back up, am I? There. Okay. So what I have going on here, I'm just going to put 1, 1, 1, 1, 1. So 5 and then 2. So I have 1 x squared. So my area of x equals 1x squared. I have 1, 2, 3, 4, 5, 6, 7 x's. And then I have forgot that line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small boxes. So here is a different way to represent it. Here's the picture that shows how I got that. Okay, next one. Here's some additional new lines of blocks that Optimus Quilts has introduced. Find 2 different algebra expressions to represent each rectangle. Illustrate with a diagram why your representations are correct. So we're going to look at this and see if we can come up with what they're looking at. So A of X equals, the original square block was extended 3 inches, so that's a plus 3 on one side and 4 on the other, X plus 4. So when I draw this, I've got an X with 1, 2, 3 on one side, and the other side has 1, 2, 3, 4. So then I just need to extend these down. So that leaves me with 1x squared and 1, 2, 3, 4, 5, 6, 7 x's, and then 3 by 4, that's 12 small boxes on the side. All right, this one, the original square block was extended by 4 on one side only. So that means the other side is still an X. So I have my original here, and I only extended 4, 2, 3, 4 on this side. So I have an X squared, and I have 4 X's. Now, if I look at some of these, there's a couple of things I notice. This one is just a distributed, right? X times X x times 4, x squared, 4x. In other practice problem videos, we've looked at some of these where I've done x squared, x times 4, because I have each of those on here. And then I have to distribute my 3 to both. 3x plus 3 times 4 is 12. I add my two x's together to get 7. So the distributive property does work with this as well. Let's look at this next one. The original square block was extended 5 inches on each side. Now we could actually put a squared here, but because I want to be able to work this out, I want to show both dimensions. So here I have 5 going down this way, and I'm going to have 5 going across this way. So 1, 2, 3, 4. Let's see if we can get one more down here. 5. 1, 2, 3, 4, 5. I had plenty on that side, huh? So that equals x squared plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 x's plus, I have 5 across and 5 down. That's 25. And if I look at my distributing, x squared plus 5x plus 5x plus 25. 2 5s gives me a 10. Okay, so let's see if we can find some sort of pattern as we're doing these to finish off this page. So here my original block was extended 2 inches on one side and 6 inches, x plus 6, on the other. So if I were to make this box, we're going to have 2 down here, then we're going to fit 6 over here. So here's my 2, and then I'm going to have the 1, 2, 3, 4, 5, 6. So I know it's going to be equals 1x squared here, 1, 2, 3, 4, 5, 6, 7, 8, plus 8x's plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 12. Now let's see if we can figure out some connection between this number here and these two. Well, 2 plus 6 gets me 8. Well, what do I do with 2 and 6 to get 12? Well, 2 times 6 equals 12. So it looks like I'm going to have an x squared in the front, right? There's no multiplier in there. I'm going to add my numbers at the end, my extensions. I'm going to add those to get my b, and I'm going to multiply them to get my c. See if that works over here. So customers started ordering custom-made blocks designs by requesting how much additional area they want beyond the original area of x squared. Once an order is taken for a certain type of block, customer service needs to have specific instructions on how to make the new designs from the manufacturing team. The instructions need to explain how to extend the sides of a square block to create the new line of rectangular blocks. Customer service department has placed the following orders on your desk. For each, describe how to make the new blocks by extending the sides of a square block with the initial side length of x. Your instructions should include diagrams, written descriptions, and algebraic descriptions of the area of the rectangles and using expressions representing these lengths. Okay, so they've given us this information. So there's a couple things we can do. We can look at this and say, we have just split those into 2. So let's go to our original. If we were to combine this, we've got x squared plus total of 8 x's plus 15. Well, we just said the side length is going to be x and then the x here. It's two numbers that add to get 8, multiply to get 15. Well, 5 and 3 just added to get 8. Do 5 and 3 multiply to get 15? Yes. So our diagram should be one side is a plus 5. I'm better doing this side long. And one side should be a plus 3. Uh, 1, 2, 3, 4, 5. Okay, so this shows that I have x and 3, x and 5, and I end up with 8 x's and 15 little squares. All right, so let's try number 7. Let's do this guy in purple since we're kind of getting crowded. I have 4 and I have 6. So first I'm going to do x squared plus 10x plus 24. Well, I need to have two numbers that add to get 10, multiply to get 24. 4 and 6 added to get 10, 4 and 6 multiply to get 24. So this one we're going to put over here. I need to have an x plus 6 and an x plus 4. We'll do 6 on the side. There we go. X plus 4, x plus 6. We have now shown that those work together. Okay, so this one got 9 and 2. So it's going to equal x squared plus 9 plus 2 is 11x plus 18. Well, I need two numbers that add to each equal 11 and multiply to get 18. Look at that. 9 and 2 add to make 11. 9 times 2 is 18. So x plus 9, x plus 2. And so that one is going to be a little tricky. We'll do 2 down below to make this plenty long for my 9. Look like a flag. So here's my x plus 2. And now I need 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. It shows 11 x's and 18 boxes. All right, last one. Got 5x and 1x. So x squared plus 6x plus 5. We know that's going to equal 5 plus 1 is 6. 5 times 1 is 5. X plus 5, x plus 1. So this one is going to be, we're going to just do 1 across here. 1, 2, 3, 4, 5. So here's our x plus 5, x plus 1. So now we have described each of these in a couple of different ways. I think we needed 2, right? All right. Some of the orders are written even more simplified, in more simplified algebraic code. Figure out what these entries mean by finding the sides of rectangles that have this area. Use the sides of rectangles to write equivalent expressions for this area. So here, I'm going to start by looking at 10. What are the different factors of 10? 1 and 10, 2 and 5, and that's it. So I know I either need 1 plus 10 or 2 plus 5 to equal 11. I'm not going to circle that. Let's underline it so we show it slightly different. Equal 11. 1 and 10 equal 11, 2 and 5 equal 7. So this is the one I'm going to want. So that tells me I need an x plus 1 and an x plus 10. When I add these two, I get 11. When I multiply these two, I get 10. So that one works there. So again, with 10, this time I need them to add to 7. In this case, 2 plus 5 equals 7. So for this one, it's x plus 2 times x plus 5. So 2 plus 5 is 7. 2 times 5 is 10. So that's how we can break that one down into the two different types. Let's do the next page. Just cruising with these guys. All right, so now let's see if we can break up these guys and figure them out. Okay, so I need factors of 8. So I'm just going to do this over here. 1 and 8, 2 and 4, and that's it, right? Those are the only numbers that multiply to get 8. So I'm going to look and see. I need to equal 9. 1 plus 8 is 9. 2 plus 4 is 6. So for this one, I need 1 plus 8. So it's going to be x plus 1 and x plus 8. For this next one, I have 8, but I need them to add to 6. Well, 2 and 4 added to make 6. So it's going to be x plus 2, x plus 4. Added, they get 6. Multiplied, they get 8. All right, this next one we're looking at 12. So 1 and 12. Kind of connect there. 1 and 12. 2 and 6. 3 and 4. So I'm just going to put a little plus in here. 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. So let's see which one I'm going to need for this one. 8. I need them to add to equal 8. So that is going to be this guy right here. So x plus 2 and x plus 6. Added, they equal 8. Multiplied, they equal 12. Next one. We need them to equal 7. So I'm going to go over here. 3 plus 4 equals 7. So I need to do x plus 3 and x plus 4. Added, they equal 7. Multiplied, they equal 12. And for my last one, I need to equal 13. Well, 1 plus 12 equals 13. So I need x plus 1 and x plus 12. 1 plus 12 is 13. 1 times 12 is 12. So that's how we can kind of break those down, looking at the factors and deciding which ones add to get my center numbers, my b. So what relationships or patterns do you notice when you find the sides of rectangles for a given area of this type? Well, we find the factors of C and add them together to get B. So it needs to be, if it's in the trinomial form. So when we have, start a different one here. When we have x plus h times x plus g, we'll use those for our letters here. We need to get b, you add h plus g. To get c, you multiply h times g. So when we go from this to the trinomial, this is the pattern we go. When we go from the trinomial to the split way, the multiplier side times side, we go this way. So that's both directions right here. Okay, a customer called and asked for a rectangle with the given area given by x squared plus 7x plus 9. The customer service representative said the shop couldn't make that rectangle. Do you agree or disagree? How can you tell? Okay, well, let's see. If we have x squared plus 7x plus 9, first we're going to look at this 9. So the factors of 9 are 1 and 9, 3 and 3. Well, 1 plus 9 equals 10. 3 plus 3 equals 6. So neither one of these matches a 7. So we agree with the service rep. We agree. The factors of 9 don't add to get 7. So this is not a rectangle they can do. Right. Thanks for joining us. That's all we have for today.